Good evening everyone, I am Mr. Ish. Thank you for joining me. We are looking here at this question, 0 to infinity and integral x cubed e to the minus x dx, a product of two different functions. You know integrating by parts will come into play over here. Successive rounds until we come here at a good antiderivative. Let's solve this. X cubed e to the minus x. Start with your first round of substitution. For your integrating by parts technique, you know you will do u is equal to x cubed, then we'll do du is equal to 3x squared dx. You'll do v is equal to the integral of what remains. You know this right here is integral to your procedures for the integrating by parts technique. It's e to the minus x dx, and that's minus e to the minus x. You'll bring everything here to the first round. uv minus integral v du. Bring the items in, u and v. I have u is x cubed, v is that. I'll bring minus x cubed e to the minus x. This minus is coming from here attached to this uv. As you see, uv minus integral v du. I have here minus e to the minus x. Then I have a 3x squared dx. Now what we can do is simplify a little bit here before we go ahead. I have a minus and a minus, it'll become a positive. I have a constant, I'll bring that out. So what I'm left with here is this, e to the minus x, x squared. Now we begin the second round. The second round you're focusing right here. U is equal to x squared. These limits will come in at the very end. The beauty of the integrating by parts technique is you can push the limits outside till the very end and bring them back in. Your limits do not change. U is equal to x squared. Du is equal to 2x dx. V is equal to the integral of what remains, e to the minus x dx. You know that's minus e to the minus x. Now we do another round right over here. I have here minus x cubed e to the minus x plus 3, and then I'm doing here uv minus integral v du, and you know that. But for convenience sake, let's remove this and let's bring in the substitutions. uv, I have a u and a v. There'll be a minus x squared e to the minus x. Same thing, minus is coming here and I'm attaching with that. Then I have a minus integral v du. I have a 2x in that. Minus e to the minus x, 2x dx, close the parentheses. Focus right here. The minus and the minus will become a positive. I have a constant, I'll push it out. And then I'm looking at just this, e to the minus x, x. Now, what we can do if we want is open up everything, or we can just leave everything as is for now. Let's do another round of substitution for this part right over here. And we can do it right over here. I'm doing another round. U is equal to x, du is equal to dx, v is equal to the integral e to the minus x dx, which you know minus e to the minus x. Here you'll do another round. As we do it, we'll open this up. I have here minus x cubed e to the minus x plus 3 in that minus 3x squared e to the minus x plus 3 and this 2 plus 6. And then I'm looking over here for this part where you have a uv minus integral v du coming in here based on those substitutions. But let's bring them in, and we will do so. We know over here u and v, minus e to the minus x, and that it will be a minus x e to the minus x minus integral v du. Du here is just a dx, so your substitutions have exhausted and you won't have to do another round. This will take you through completion. You'll have v here, which is a minus e to the minus x dx. We'll close the parentheses out. Now we have to open this up. When we open it up, we'll bring everything here in a good clean manner. What will that item be? Well, I will have over here minus x cubed e to the minus x. Then I have a minus 3x squared e to the minus x. I have a 6 and then a minus. It will become a minus 6x e to the minus x. Here I have a minus and a minus. This will become here a positive. When you look over here at this part, it's just going to generate here minus e to the minus x as your antiderivative, which will impact with the 6 sitting outside. It will become a minus 6 e to the minus x. And now you have your antiderivative, and we bring in our limits. I have an infinity and I have a 0. Now it can become a little tricky bringing in the infinity and the 0. There's a trick. Use algebra and simplify it. If I'm looking here, I have a commonality, and that commonality is a minus e to the minus x. And then I'm looking at everything else. I have here an x cubed. Then I have here a plus 3x squared. Then I have here this plus 6x plus 6 and I'm looking at everything from infinity and 0. Now it could be tricky still to deal with those limits, especially when you have all of these various items and variables. Simplify once more. I have a minus e to the minus x. Get rid of this minus e to the minus x and do this. Bring the minus over here and bring the e to the x here in the denominator. It helps out, and I'll tell you why. Because you exhaust some items simply by the limit values. I have an infinity and a 0. This is what we have to do, and the procedures have been laid out for you. I'm going to clean all of this and then we'll compute this definite integral result, which will be the area below the curve for this function right here from 0 up to infinity, an improper integral. Now when you put in the infinity, what happens is this. You can do it like this, minus 1 over e to the infinity, and then you can keep everything as is. This is just the upper limit coming in. I'm not even bothering putting anything over here, because this right here is equal to a minus 0 times everything over here, which is equal to a 0. When you put in the first limit, you're really having here is 0 come out. From the infinity placement, you have a 0, because the denominator with the infinity coming, 0 is everything out. Then you have a minus. Then you're looking at this minus, and now you're putting a 0 in places of everything. When you put 0 in places of everything, you have a 0 cube plus 3 times 0, which is 0, plus 6 times 0, plus 6 divided by e to the power 0. This right here is with the second limit. This right here was with the infinity coming in, you zeroed out. This right here is with the 0 coming in. And now you have to take this to completion. When you take it to completion, this is what you have here, 0, then this becomes a plus. I'm looking here at a 6 over e to the 0, which is equal to 0 plus 6 over 1, which is equal to 6. The 6 here is our end result for this. This right here is equal to 6 in terms of its end result. It will be a correct answer, which brings our video here to an end.